All right, so we're going to take a look at a couple application problems to see where this kind of fits into geometry. And one of the things that we need to do is deconstruct the vocabulary so that you can actually draw the picture that they need us to draw. So it says find the area, so we're using area here. And it says of a regular octagon. So regular means all sides are equal. Octagon means 8 sides. So I'm going to draw an octagon, which looks like a stop sign. And I'm going to do my darndest to try and get it to be the correct shape. And although I'm seriously a bad artist, let's see, 1, 2, 3, 4, 5, 6, 7, 8. All right, so we've got our 8-sided octagon. We're going to pretend that all these are the same length because this is about as good as it gets. And then it's inscribed in a circle. Now, inscribed in a circle literally means that the points where the segments come together on the octagon are literally the points of the circle. So something like that. So we've got a circle. We've got our octagon inside the circle. And it says the radius is 40. So you know a radius is from the center point of your circle to the circumference. That's a radius. So if I draw 2 radii, I now have an isosceles triangle. I have 2 sides that are equal, and they're both going to be 40 centimeters. That's what the radius is. And I have a triangle that I can actually find the area of. There's only one problem. What is this angle right here, this vertex angle? And the way we figure that out is the fact that it's a regular octagon. And because it's regular, that means that we have 360 degrees and we're dividing it by 8 equal pieces. We want 8 equal pieces. And when we do 360 divided by 8, we get 45 degrees. So this is a 45-degree angle. And now that we have 2 sides of our triangle and the angle that's formed between them, we can do our area formula. So K equals 1/2 AB sine C. Now the 2 sides are the sides that are the radii, so that's going to be 1/2 times 40 times 40. And then the angle that's formed by those radii is 45 degrees. And that is going to give us the area of this first triangle. So I'm going to grab my calculator and do some fancy work here. So I've got 1/2 times 40 times 40 times the sine of 45. And I'm getting approximately 565 point, we'll go 7. Okay, and that's in square centimeters. But this is just for one triangle. This is one of them. And because it's a regular octagon, that means that if I keep making them, if I keep connecting them, here's one, here's one, here's one, here's one, here's one, here's one, I'm going to have 8 equal slices. 8 equal slices, which means that I have to take this area of one of them and I've got to multiply it by 8 to get the area of the entire octagon. So I'm going to take this value right here, 565.7, and multiply by 8. And this is about 4,525.6 square centimeters in area. So there's the application. of when to use this. Now, this said octagon, it didn't say triangle, but we know that regular means equal pieces, so we wanted to partition it and turn it into a slice. And then once we found the area of one slice, we just multiplied by 8 to find the area of the rest.